Welcome to Engineer's Mindset. So let's say we are given the beam and we are asked to do the shear force analysis and also draw the shear force diagram for the beam shown. Okay, so first thing first, free body diagram. Okay, so outline the free body diagram of the beam. So at point A, this is a pin. So for a pin, we already know you have the vertical reaction, so RAY, and the horizontal reaction, RAX, for a pin support. Okay, at point B, we have a 5 kilonewtons force, 5 kilonewtons. At point C, we have 2 kilonewtons force, 2 kilonewtons. And at point D, we have one support, a roller support, so we have just one reaction, RDY, vertical to the surface or normal to the surface. So this is point C. Distance apart, this is 2 meters, this is 3 meters, and this is 2 meters. Okay, so before we can be able to do the shear force analysis, we first of all have to determine what these reactions at A and the reactions at D. So that is the essence of the previous videos we have been doing. So go back to the previous videos for proper understanding of how to determine reactions at support. Okay, the first thing is actually employing what? Static equilibrium equation. So from static equilibrium, okay, law, or from static equilibrium law, we have summation f of x equals 0. We also have summation f of y equals 0. So let's start with summation f of x equals 0. So you look at the beam, sum all the forces that points to the x-axis and equate it to 0. So in that case, we only have just RAX on the beam pointing to the x-axis. So this now implies that RAX is actually what? 0. So we have that. Next is to employ summation f of y equals 0. So we sum all the forces in the y-axis and equate it to 0. So notice vertically upward force as positive and vertically downward forces as negative. So we start. We have RAY at point A pointing upwards, so it's positive. So pick it out. RAY. Next, we have 5 kilonewtons force pointing downwards, so it's negative, minus 5. Next, we have 2 kilonewtons force pointing downwards, so it's negative, minus 2. And then we have RDY pointing upwards, positive, plus RDY. And that's equal to 0. Okay, so this is actually saying RDY minus 5 minus 2 is actually minus 7 plus RDY equals 0. So let's send minus 7 over to this side of the equation. Negative sign plus sign equal sign becomes positive. So we have RAY plus RDY, that's equal to 7. Call this equation 1. So equation 1 is now what? One equation having two unknowns, so it's very much impossible to solve. So if you are following the series, I said at this point what to do is simply what? Take moment about the point where we have numerals of force. So we have forces at point A, about 2 forces at point A. So we'll simply take moment of force about point A. So take moment at A. So we said summation of the entire moment at point A is equal to 0. Let's take clockwise moment to have positive, anti-clockwise moment to be negative. So if that's the case, since the moment of this force is about point A is 0, then we'll take moment of this force about point A, moment of this force about point A, and then finally moment of this force. So let's start with 5 kilonewtons force. This force is pointing downwards. Moment of this force about point A goes in this direction, clockwise. It is clockwise to our direction. Okay, so it's positive. So it goes all the way from this point to point A, which is clockwise direction. And total distance it takes to get to point A simply what? 2 meters. So moment is simply force times distance. So we simply have 5 times 2. Also, the 2 kilonewtons force also what is acting now, so it goes all the way in this direction to take moment about point A. So it's also clockwise, so it's positive. Distance it takes this force to get to point A is simply what? 3 plus 2. Okay, that's 5 meters. So we'll have plus 5 plus 2 times 5. And then finally we have RDY pointing upwards. So if it goes upwards, so the moment will be about this direction, which is anti-clockwise. So it's negative. So if it moves all the way from this point to the moment about point A. So the direction is actually what? Anti-clockwise, which is negative. Total distance it takes this force to get to point A is simply 2 plus 3 plus 2. And that's 7 meters. Okay, so we simply have minus, because it's anti-clockwise, R dy times distance 7. That's equal to 0. Okay, so we'll expand the brackets now. 5 times 2 is 10, plus 2 times 5 is also 10, minus this is 7 R dy. That's equal to 0. So 10 plus 10 gives us 20, minus 7 R dy is equal to 0. So let's send minus 7 R dy over to this side of the equation. Minus plus and equal to sign becomes positive. So we have 20 equals 7 R dy. So to make R dy subject, divide both sides by what? 7, which is the coefficient of R dy. So that simply implies that R dy is simply 20 divided by 7, and therefore R dy is equal to 2.9 kilonewtons. So R dy is simply 2.9 kilonewtons. So having known R dy, simply we substitute R dy into equation 1 to obtain R ay. So substitute into equation 1, substitute R dy into equation 1. If we do that, we simply have RAY plus, in place of RDY, we simply have 2.9, and that's equal to 7 kilonewtons. So that's equal to 7. Okay, so to make RAY subject, simply send plus 2.9 over to this side. Positive sign, constant, equal to sign becomes negative. So that simply implies that RAY is now equal to 7 minus 2.9. Therefore, RAY is equal to 4.1 kilonewtons. We have that. Okay, so having known the values of the reactions at point A and reactions at point D, we can now start the shear force analysis. So what you do is this: to start the shear force analysis, you simply bring backwards the beams with their reactions. Okay, so that's what we're going to do now. Okay, so alright, so we bring back the beam and then introduce the reactions. So RAY, already RAS was determined as 0, so that's off. RAY gives us 4.1 kilonewtons, so this is point A. So we'll have RAY, which is 4.1 kilonewtons. Next force is at point B. So at point B we have a 5 kilonewtons force. Next force is at point C. At point C we have a 2 kilonewtons force. And then finally we have RDY at point D. Okay, this is point D. RDY, and the value for RDY was 2.9 kilonewtons. So we have 2.9 kilonewtons. Alright, so we can now start the shear force analysis. Shear force simply means the summation of the entire force acting on the beam from beginning of the beam at each point of the beam to the end of the beam, considering upward forces as positive and downward forces as negative. Okay, so we'll start from the beginning of the beam, stepwise from beginning to the end. Alright, so this is what it means now. So we'll start from the very beginning, which is at point A. So shear force, SFA means shear force at point A, is simply equal to the force that exists at point A that particular force that exists at point A becomes the shear force at point A. If that force is pointing vertically upwards, it is positive. But if the force is pointing vertically downwards, it is negative. So we simply have that shear force at A is simply what? Which is RAY, and it's pointing upwards, so it's positive. You simply have 4.1 kilonewtons. So this is the shear force at point A. Now, this same shear force moves from point A down to point B. So we have shear force at point B prime, which means initially this same force moves from point A to point B initially. So it is still the same intensity of force that moves. So we have 4.1 kilonewtons. So that same force moved from point A down to point B initially, and the value still remains. The value still remains 4.1 kilonewtons. But at point B now, it now encounters what? A downward force of what? 5 kilonewtons acting downwards. So we simply have shear force B prime prime, which means finally at point B, this force 4.1 kilonewtons now encounters what? A downward force of 5 kilonewtons. So we simply have minus 5 because this force is acting what? Downwards. So shear force B prime prime is simply 4.1 minus 5, and that is actually what? Which is minus 0.9 kilonewtons. So this 0.9 kilonewtons force moves from point B down to point C. So we have shear force C prime, which means initially at point C, the same force moves from point B to point C, and that force is simply minus 0.9 kilonewtons. But finally at point C, it now encounters what? A 2 kilonewtons force acting downward. So we have shear force C prime prime, okay, which means finally at point C, this force now encounters what? The minus 0.9 force now encounters a 2 kilonewtons force acting downwards. So we have minus 2, and this is now equal to minus 2.9 kilonewtons. Okay? This minus 2.9 kilonewtons force moves from point C down to point D. So we have shear force D prime. So it moves from point C down to point D. Initially, it still remains minus 2.9 kilonewtons. But on getting to point D, it now encounters an upward force whose value is also what? 2.9 kilonewtons. So you simply have shear force D prime prime, which means finally at point D, the minus 2.9 kilonewtons force now encounters an upward force of 2.9 kilonewtons. So the value is simply what? 0. So take note, at the end of every shear force analysis, you must always have 0 as the answer, for sure. At the end of every shear force analysis, you must always obtain 0. The same thing applies to bending moment analysis. At the end of every bending moment analysis, you must always have 0. Alright, so this becomes the shear force analysis for the beam. So the next thing to do now is to simply what? Draw the shear force diagram. Okay, so to draw the shear force diagram, we have to invoke back the beam. So bring back the beam, and okay, at point A we have RAY, which is 4.1 kilonewtons. Point B we have 5 kilonewtons force. Point C we have 2 kilonewtons force. And then point D we have RDY, which is 2.9 kilonewtons. Okay, so what you do is simply trace down all the points. This point B, this point C. So trace down all the points. Okay, so this is actually freehand sketch. You can use a graph to plot this, but this is freehand sketch and it's highly permitted, it's highly allowed. Okay, so trace down all the points. Trace down all the points. Okay, so you look now at the shear force analysis and obtain your highest value. Okay, so the highest value is simply what? 4.1 kilonewtons, followed by 0. Okay, followed by 4.1 is the highest, and the rest are negative, minus 0.9 and then minus 2.9. So you pick out your origin. let this be the origin of your graph. So at the origin, everything is 0. So above is positive, below is negative. So the positive value we have is simply 4.1 kilonewtons. So choose some right here, call it 4.1 kilonewtons. Okay, below is negative, so we have 0.9 kilonewtons. So this is below, which is minus 0.9 or 0.9 kilonewtons. Okay, and then we have 2.9 minus 2.9, so it's below. So this is minus 2.9 kilonewtons. So after this, you trace out these points, trace them all out to the end, trace out each of the points, all out to the end, trace out each of the points to the end. Alright, so you can now start your shear force diagram. The shear force at A is 4.1 kilonewtons. This is line A, this is 4.1, so you simply what? Asterisk. Okay. Shear force at B, please take note, shear force at B prime simply means finally at point B. So this is what we are using, not B prime. So shear force at B, we have minus 0.9. So this is B, and this is minus 0.9 to asterisk. Okay. Shear force at C prime, which is shear force at point C, is minus 2.9 kilonewtons. This is line C. This is minus 2.9, so asterisk. And then finally, shear force at G is given as 0. Okay, this is line G, and this is the 0 mark, so asterisk. Okay, so we start from the origin to locate point A, shear force at A. So from origin down to point A, we have shear force at point A. Now this same force moves from point A down to point B. And then at point B, it encounters a downward force of 0.9 kilonewtons. Okay, the shear force at point B is minus 0.9. So from point B, we will encounter 0.9. This 0.9 kilonewtons force moves from this point to point C. Now encounters this other shear force at point D. Then from point D, this same force moves from point D down to point. This force moves from point C down to point D. And at point D, we encounter an upward force of 2.9 kilonewtons, which is, so you connect it up, and then you have it. So you can shape. So this becomes the shear force diagram for that. Alright, so that becomes the shear force diagram for that. Okay, so that's how you can plot shear force diagram for simply supported beams. Point notes. Next, we are going to talk about UDLs and UVLs and how you can do their shear force analysis. Alright guys, thanks and cheers.